All right, guys. I am going to teach you guys a little bit about speed and graphing. I know it has been a long time since we really even looked at graphs. I'm just going to give you a brief little bit about it here. And I've also got a video posted on our task board that shows you a little bit more about how to calculate speed. So the first thing I want you to know is speed is how fast or slow an object is moving. And you're like, okay, thanks, man. Yeah, I know you already know that. Wanted to make sure we could start somewhere common. But I want to tell you the formula. To figure out speed, it is distance divided by time. And I know that sounds crazy, but I want you to think about when you have been in a car, you don't look at it and say, oh, we're going 60 miles when you're on the highway. No, you're going 60 miles an hour. And so what that means is in 1 hour, you would go 60 miles. So the example I have down here is 40 miles in 4 hours. Well, the distance is 40 miles and the time is 4 hours. So how would you figure out the speed? Well, 40 divided by 4 is 10. So that speed would be 10 miles per hour. And honestly, for fifth grade, your distance divided by time to figure out speed is not really going to be anything too crazy. A lot of times, numbers in the problems are used that work out pretty nice and neat, like 40 divided by 4. And like I said, I've got a video that goes a little more in depth that I tagged to this. Now I want to we're going to look at a couple different types of graphs that you're going to see, and I want to just kind of show you so you can tell quickly. At the end of this video, I want you to be able to tell just quickly looking at a graph, is it increasing, is it decreasing, or is it constant, which means it's not changing. The two examples I have here for increasing, one of them, you can see the larger one here, the line starts lower and moves higher. The straight line, just like this, is increasing. It's going up. As time increases, so does the distance. Everything's moving up. That shows an increase. The one next to it, you see kind of a curve, and you don't have numbers that go with it, but you can tell, oh, that one's moving up because as it goes, it's curving upward. And this is actually incredibly relevant to a lot of the stuff that you're seeing on the news where, they keep talking about the COVID-19 and they're talking about flattening this curve, and you'll see, I'll show you that next. So now when we talk about decreasing, that line in the first one, the larger one, the straight line, boom, it starts higher and then moves lower. And that shows a decrease. Okay, moving like this. But the other one, you can see where it's curving downward, it shows that it's slowing down. It might start going up, but once you see it start to flatten the curve, as you've probably heard on the news, that means the numbers are declining. It's starting to slow down because it started going up, but as it starts curving down, you can see that the speed is decreasing. And a lot of the graphs, most of the science graphs that we would look at in fifth grade do deal with speed. Here's where it gets a little funky. It's where it's no change, and it's when the line is straight across. Now that can mean two things, and it's going to depend on what is on your graph. A line that is horizontal either means that the object stopped moving or it's constant. And that's going to depend. If you look on the y-axis of these two, the one where I have stopped underneath, your y-axis is distance. That means the distance has not changed. They haven't gone any farther. Well, if an object's distance hasn't changed, that means that object is not moving. But if you look at the other one, where I have it circled in blue, and at the bottom it says no change in speed. It says constant. The difference there is the speed is not changing. Your y-axis is speed. So the speed stays the same, meaning it's moving at a constant pace. So this straight line across means there hasn't been a change. It's going to depend on what your y-axis says as to whether or not that means it has stopped or the speed has stayed the same. And here I just want to show you a graph that, not all graphs just move straight up. And you could actually see that in those two where they kind of curved one way. So here at the beginning, I have a couple slides on this. You can see that the speed starts off increasing and is increasing at a great rate. The more straight up and down that line is, the faster it's either increasing or decreasing. The more vertical that line is. So right here, the section I've circled in red shows that the speed is increasing. Okay, next, the line is straight across, but my y-axis is speed. The speed is not changing, so that means it's moving at a constant speed. The next section of the graph, it starts to decrease. So this might be a little chaotic here, showing increasing, constant, and decreasing. The reason why I have all of those circled there is because I want to explain that at the x-axis at the bottom, it has time. So from 0 to 10 seconds, the speed of the car is increasing. But from 10 to 20 seconds, the car is going at the same speed. So this car gets up to 40 miles an hour, and then it just stays going at 40 miles an hour. But at the 20-second mark, you can see that the driver of the car must have hit the brakes because the speed starts to decrease between seconds 20 and 30. And it drops all the way down to 20, I'm assuming, miles per hour. At the 30-second mark, you can see it starts to move upward again, so that would be increasing. Again, this was just a little introduction into looking at graphs. Hopefully, now you can tell when you look at a graph when it's increasing, it hasn't changed, or it is decreasing.